All right, we are now looking at repeated string in the warm-up challenges. So the basic idea is we have this string S. So here it's ABCAC, and it's repeated infinitely many times, and we're given some number n, which is the first number of letters in this infinite string that we want to look at, and we want to count the number of A's that appears in this string that we end up with. So the real sort of the difficulty with this is that you can't really what you might want to do is you might want to be like, okay, let's construct this string by taking this string S that we have, and then we just repeat it multiple times over and over again until we have the correct number of repeats, and then literally go through this resulting string character by character and see if each character is an A, and if it is, then you increase your counter by 1, and if not, you just skip it. But if the big issue with this is that if we look down here at the constraints, sure, this string S that's being repeated, its length is going to be less than or equal to 100, so that's not too bad. However, the number of the length of the string that we're looking at, the first n characters that we're looking at, this can be really large. So it can be as big as 10 to the 12th, and it even sort of hints you in this direction by saying for only 25% of the test cases is n less than or equal to 10 to the 6. So you need to write a program that can work pretty efficiently. So basically what we have to do here is we have to try to automate things. And so the main idea is that, so we can take this string S and we can count how many A's are in it. And we can also do some division to figure out how many full occurrences of the string S will appear in the first n characters. So let's say, what example do they give us? S is 1, 2, 3, 4, 5. Okay, well, this isn't a really good example. Let's say S was ABCAC and N was 12. Then in this case, you have 2 full instances of S. You've got ABCAC twice, and that gets you up to 10, and then those last 2 characters are going to be the A and B that are sort of repeated from the beginning. But of course, on that last sort of loop through S, you don't finish the entire string. So what we do is we count the number of times the character A appears in S, and we multiply that by how many full instances of the string S appear in the first n characters. And then for anything left over, we can count it manually. All right, so let's go ahead and start this. So the count, which is going to be just the number of instances of the letter A, we're going to start at 0. And then the first thing we're going to do is we're going to count the number of A's in the string S. And so we're going to go for I in range. Here we're just going to do sort of the simple thing. We're going to loop through the characters in S, and if it's an A, we'll increase the counter, and if not, whatever. Okay, so for all I in the range of the length of S, so this will go from 0 to the number of characters in S minus 1. If the ith character in S is A, then we want to increase our count by 1, which I believe can be done using this syntax. I'm still learning things in Python, so this is probably an obvious and common thing, but it's possible that this will give me an error. Just anytime you code something new, especially if you're doing it in front of a class or live or something, there's always a chance that you can run into an error. But anyways, so that's how, so count currently has the number of A's that appears only in the string S. And now we're going to count the number of A's in the full instances of S, or the number of A's among the full instances of S that appear in the first n characters. So we're going to define the number of full instances to be m. And so what we need to do is we need to take the n and divide by the length of S. And we want to round down to the nearest integer. So we're going to do math.floor. So this is a function which rounds down to the greatest integer lower than whatever value is on the inside. The greatest integer which is less than or equal to whatever value is on the inside. So that's what this is. And then count is just going to be the value that we had before, and we're going to multiply by m. So now we're going to have the number of A's in the full instances of S. And then all we have to do is count the remaining A's, or the remaining number of A's. So S is the full string that's being repeated. I'm going to define an additional string S called S2. This is going to be S, except we shorten it so that it stops once we've hit n characters overall. So we're going to go from 0 to n minus m times the length of S. Because the first m, or the m full instances of S, the number of characters that will take up will be m times the length of S, and we take n minus that value to get the ending index. And of course, because we're indexing and indexing starts at 0, you always want to check for yourself mentally that you're not off by 1 here, but this works out. Okay, so then for I, then what we do is we just count the number of A's in S2 and we add that to count. And we do this in the same way that we did before. So for I in range length of S2, if the ith entry of S2 is A, then we're going to increase count by 1. And that should do it. So then we return count. And now let's check this. It seems to work, but really getting this to work was never really the big issue. The big issue is making sure that it runs quickly enough that you can get through 10 to the whatever number of entries in, or to be able to account for how large n can be. And so when we actually submit the code, then it does a bunch of test cases where they will be super long, and it works. So yeah, there we go. This is a pretty straightforward code. The main thing is figuring out the most optimal way to sum everything up and knowing how to sort of access this floor function. Because it's not built into Python, you need to import math and get it from there. But yeah, that's pretty much all there is to this problem.